In the last lecture, we have looked into a new knowledge representation scheme that was called Semantic Net. We introduced the basic concepts of Semantic Net in that lecture. Prior to that, we have seen that knowledge can also be represented using rules. There are some differences between the rule based representation and the semantic net based representation. In semantic nets, if we just recapitulate for a while, you will remember that the world concepts are represented as nodes in the semantic net, and the relationships between the different concepts are denoted as edges between the two nodes. Now, there are some varieties of such representation. Anything, any entity or any concept that we represent from the world can be represented as a node. The relationships can be of different type, but most important relationship that is occurring in semantic nets, as we have seen, is the is-a relationship. For example, cat is a mammal, Tom is a boy. Okay. Now, so essentially it turns out very similar to a graph or a network of concepts and relationships. But as you will recollect that no knowledge representation scheme is worth its name unless we have a mechanism using which we can reason and infer new facts or answer questions and really do some useful work of inference. Only in that case, if we can do those, then we can certify that to be a valid knowledge representation scheme. Now, in the last lecture, what we have discussed is just the representation, its graphical structure, and we have also given a couple of examples. Today, we will be extending that discussion and will include in our discussion how semantic nets can be used to reason, so that we can infer new things or can answer questions. We will see how we can do that. So, today our objective is to look into reasoning in semantic net. Now, here is one more example, a new example which is a little different from what we did in the last class. In this case, you can see that we are trying to represent the heights of two people. Now, Chris is a person, Chris is one person and John is another person. So, the heights might be in meters or whatever, these are the values, but these are again in semantic nets we are not making any distinction between the types of the concepts, and these two concepts are linked by the relationship height. Therefore, it is standing to represent a sentence, the height of Chris is 1.9, the height of John is 1.6. Now, if we try to compare the height of these two people, now these are two statements, height of Chris is 1.9 and height of John is 1.6, two independent statements. But if we want to state that the height of Chris is greater than height of John, in that case we will have to add some extra nodes to designate that concept. So, you can see how semantic nets can be extended. Let us look at this. Here we can see that we are now bringing in two other concepts. These are constants 1.9 and 1.6. Now, the height of Chris is h1 and the height of John is h2, and we are relating, and the value of h1 is 1.9 and the value of h2 is 1.6. So, you see that we have already brought in one new relationship called value over here. Now, for the sake of comparison, what we can do, we can establish another new relationship between h1 and h2 and state that h1 is greater than h2. So, from this augmented semantic net, now we can say that, well, the height of Chris is h1 and the height of John is h2, and h1 is greater than h2. Therefore, I can compare the height of Chris and John. But you can see that in order to achieve this, we had to incorporate extra nodes for the concept as well as its value. We had to add two new nodes h1 and h2, and also we had to incorporate another relationship called value. Now, we will see more of semantics nets and the different offsprings of semantic nets later, different varieties, and ultimately semantic nets were developed, or the ideas were taken, and more powerful knowledge representation schemes were designed. But at this point of time, let us try to see how we can utilize semantic nets to reason. The basic thing, the basic mechanism of reasoning using semantic nets is the concept of inheritance. So, before going into the reasoning mechanism, let us have a look at what we mean by inheritance. Now, just read these lines a little carefully. You can see that you will realize that inheritance is a word that is very common in our vocabulary, right. People inherit property from their parents, from their grandparents, etc. So, it is getting some things from the predecessors' parents. Okay. In other words, we can extend it that say, if we say that cat is a concept and we say cat is a mammal, then cat must share or inherit some properties that mammal has. Okay. Now, the concept mammal will have some properties. So, cat being a mammal, cat is a mammal, cat will also inherit some properties of mammal. So, using this idea, AI researchers have refined the notion of basic notion of inheritance, and it is called a specialized inferencing technique for representing properties of classes. Now, at this point I want to pause for a second. Some of you who are familiar with the definitions and the terminologies of object oriented systems must be having the familiarity of classes. We have got the notion of classes and we have got the notion of objects. You will find a very close similarity, and this is no magic that there is a similarity. They are actually the same concept being refined over years of research. So, if we think of some class, and say in the earlier example, as I said, mammal is a class. Mammal designates a class of animal, okay, including human beings, and cat is a subclass of mammal. So, since it is a subclass of mammal, it inherits some basic properties of mammal. In addition, it can have some specialized features which cats have, but human beings, also being mammals, do not have. For example, we have got 2 legs, whereas cats have 4 legs, but mammals have got some common feature, that mammals drink milk. Okay. So, that property is inherited both by cats and human beings. So, there is a notion of classes and subclasses in the inheritance mechanism, and you can see that is-a relationship as we defined in semantic nets is nothing but a class subclass relationship. Cat is a mammal, so cat is a subclass of mammal. Okay. So, we want to represent properties of classes and exceptions to inherited properties. Sometimes the mechanism of inheritance will also allow us to make exceptions to the properties inherited, okay, because all the properties that are there in the class may not be there in the subclass. It is also possible that one particular concept or one particular class will have multiple parents. So, there can be multiple superclasses, and later on we will see we can have structured concepts with specific. So, each concept can have a structure within itself, and the elements of that structure can have specific relationships among them. So, that is what is known as inheritance. We will see examples to elucidate this much more. Now, as we know that in semantic nets the most powerful relationship or the most common relationship that we use is the is-a relationship. So, let us see, in order to reason in semantic nets, how this is-a relationship can be used. Semantic nets allows us to define relations between objects, including class relations. For example, X is a Y, all right. Now, so we can define, first step is we can define this class subclass relationship. X is a Y, so X is a subclass of Y. Now, only restricted inference is supported in semantic nets by the methods that is based on inheritance. So, here is an example. Fido is a dog, all right, and dogs have 4 legs. So, we can infer Fido has 4 legs. Now, if you just think a while, and then you can see that you could have also represented this using logic, but so how did it look? Fido is a dog. You can try yourself to translate that into logic, and dogs have 4 legs. So, Fido has 4 legs. That can be very well be inferred using our well known modus ponens method. Okay. For those of you who would like to just have, let us do this. So, Fido is a dog, we can say that is Fido is a dog. Dogs have 4 legs, that means I am writing in propositional form. If dog Fido, then has 4 legs Fido, all right. So, if I say this is P and this is P implies Q, then according to modus ponens, if you recall, we would have inferred using this, we would have inferred Q, and Q is nothing but has 4 legs Fido, this thing, right. So, you could have inferred this using logic also or using rules, but this sort of notations are not very common to our experience, and it has been introduced by the logicians, and it is a very powerful tool to handle with that. But using semantic nets, we can achieve the same thing. For example, if I just try to draw the semantic nets equivalent to this, we could see that okay, here is a concept dog, and dog number of legs is equal to 4, and Fido is a dog. Now, this picture very clearly shows the relationship Fido is a dog and the number of legs of dog is 4. So, now from here we can inherit, you see how inheritance can be used, that since Fido is a dog and dog has number of legs to be 4, therefore, Fido will also have number of legs to be 4. All right. Now, this property of number of legs has not been stored with Fido, because I could have had another Jim as another dog. Now, I did not store the fact that Fido has 4 legs and Jim has 4 legs. If I had to store that all the time, so if I had to store this here, again Jim has 4 legs, that would be a redundant storage that is not required, right. On the other hand, I can very well infer from this structure in a logical way. So, what is happening here? Where is the inheritance? The inheritance is here, that Fido being a dog is inheriting the property of number of legs being 4 to itself. Therefore, we can infer it. Now, so this is in general the way it is inferred, but there are some exceptions to it, of course. For example, you can say, well, if now somebody says that Fido is a lame dog, okay, then might be Fido has got 3 legs and not 4 legs. So, therefore, whenever we infer something using inheritance, that means from the parent we extract that and use that information, that is fine unless anything is known to the contrary. So, as we go down the hierarchy, as we go down to the specialized cases like Fido, if there is an exception, then Fido can, I could have said Fido has 3 legs. If nothing is stored, I will infer Fido has 4 legs, because Fido is a dog. That is why in the earlier case we had said that that is why in the earlier case we had said that there can be exceptions to such inheritances. All right. Now, here is another example semantic net. You see, now here we have written, instead of is a, I have used specifically the relation subclass, because by now you know that is a is essentially denoting a subclass. So, we have got a root node animal, and animal has part head, reptile is a subclass of animal, mammal is a subclass of animal, elephant is a subclass of mammal. Now, elephant size is large and elephant lives in Africa. So, you see each of these relationships can be, if I just club these two together, then each of these are equivalent to some sentence, and the meaning of the sentence is very clear. That is why the name semantic, which means meaning, semantic net is coming. For example, if I just, let us play a little bit with this, we can say What does these two nodes, if I cluster them together, what does it mean? It means reptile is an animal, mammal is a type of animal, elephant is a mammal, elephant lives in Africa, elephant, the size of elephant is large, all right. And now look over here, Nelly is an instance of elephant. So, Nelly is a particular elephant, just like Fido was a particular dog, Nelly is a particular elephant, and so we are saying that we could have done it easy. Now, if we say easy, then there is a problem. That is why we need to specify it a little bit. If I had said all these are easy, then Nelly is an elephant or is an elephant. Okay. What would that mean? That would mean, is Nelly a class of white elephants which are rather small, or which we have got 3 tusks or something of that sort? Is it another variety of elephants, or is it a specific elephant? Now, merely if we use the term the relation easy, that is not very much clear. Therefore, easy is being substituted here by 2 distinct relations, one is instance, one is subclass. Now, those of you who are again familiar with object oriented programming, gradually you can try to map. You see, there is a class, there can be subclasses of classes, and there can be objects belonging to those classes. These objects are nothing but instances, right. Like Tom is an instance of a boy, all right. Boy is a subclass of person or subclass of male, etc. All right. So, here you see, instead of easy we have used another relationship, that is called instance. So, Nelly is an instance of elephant, Nelly is a particular elephant, and Nelly likes apples. Now, over here if we try to ask some questions, for example, if it is asked what is the size of where does Nelly live? Suppose that is a question, where does Nelly live? Now, naturally if we write a procedure that will search through this graph, then what would you do? We would first start with Nelly, okay, because the question, the query itself has got Nelly. So, Nelly, where does Nelly live? So, Nelly, but right now first we will search over here whether there is any answer lying at this level, whether there is any relation with Nelly saying Nelly lives in somewhere. No, it is not there. So, then what do we do? Then we think, is Nelly an instance of some other class, or is it a subclass of something? Say we find that Nelly is an instance of elephant. So, although I did not find the answer here, I go one level up and see whether the answer is available over there. I can see that, well, Nelly is an instance of an elephant lives in Africa. So, my answer will be Nelly lives in Africa, all right. Now, if the question was asked as, does Nelly have a head? Then let us see how do you do. We would have started from Nelly. Now, Nelly is an instance of an elephant. Now, here we do not find any answer to this, because whether it has got a head or not, there is no relationship called has part. So, I do not find the answer here. I go up one level high. So, because elephant is a subclass of mammal and I search for this, no, it does not, I do not have an answer here. So, I again go up to animal, and there I find that yes, animal has part head, therefore, Nelly has part head. Now, those of you who are interested, I would rather suggest that you also try this example out, the same just translate this example into logic and see how the inference proceeds in that case. Now, so whatever we have described, let us summarize what we have described. So, how did you infer? We inferred by traversing the network, the semantic network, and with that we found that Nelly has a head, and that was purely by inheritance. right. We inherited the property of Nelly having a head here. The property was much higher, and that has been inherited along this arc to Nelly. All right. So, and also we can find that certain concepts are related in certain ways, like apples and elephants. How are they related, apples and elephants? Nelly likes apples, but it really does not say whether all elephants like apples. So, as we go up, it is a generalization. As we go down the hierarchy, there is a specialization. So, although Nelly is an elephant, is an instance of elephant, it is a particular elephant, and Nelly likes apple, but that does not mean that all other elephants will like apple. All right. But meaning of the semantic network was not always well defined. Even in this case, there are all the meanings are not very much clear from this description that we have given. For example, we cannot really say are all elephants large or just typical elephants large. That probably in this case where we have in the real world, maybe all elephants may not be very large, but as we have done over here, it is apparent that we will infer all elephants to be large. We have got no other option here. Do elephants live in the same Africa? I mean, such are complicated meanings which we may like to ponder on. Now, when we really write a program that will perform such inferences, we cannot allow such ambiguities, and we will have to do away with such ambiguities. So, so in general, I hope it is clear that how the mechanism of inheritance works. To summarize, a subclass will inherit the properties of, can inherit the properties of the parent class. Now, there can be instances or subclasses. Now, instances or subclasses may have some additional properties which may be changed, right. So, for example, somebody inherits a small house from his parent, and then he can change it to a large apartment. Similarly, the specializations or the subclasses can override or change the basic properties from those that were there with the ancestors. Now, it is necessary to distinguish between two very important categories of properties. One is the default property and this is the generic property. Generic properties are always inherited. Okay? Properties are always inherited. For example, Fido is a dog. Dog is a animal, but this is not a grammatical error, okay, because we are talking of is a relationship. In English, it should be dog is an animal. So, hence Fido is an animal. This is inherited. These properties are generic to the superclass, the original class, and whatever is there in the original class, if that property be generic, then that value will be inherited, and we do not change that. Generic properties, there can be three types of properties you can think of: generic, default and other. Now, generic properties are usually not changed unless there are some special circumstances. For example, if we have got mammal, then mammals are warm blooded species. So, any cat, dog, whatever, human beings, that generic property will be inherited. All right. Besides that, there can be default properties. Now, what is the meaning of default? What is the meaning of default property? Default means if nothing is known to the contrary, inherit the value. All right. Here is an example. If nothing is known to the contrary, I know Fido is a dog, and suppose dog has part tail. Therefore, what should we infer? We will have to infer that Fido has tail. Okay. So, there is no exception to this, all right. So, if we have this, that dog has tail and I have got Fido is a dog, then I can say that Fido has tail. Now, this property, you see, this is the property link, has part is the property link and tail is the value, all right, of that property. Now, Fido is a dog and has part tail is fine, but if I have, so therefore, if I look at Fido, then I will inherit this and I will say it also has part tail. But if it is said that no, Fido is a specific dog, now this is a, but this is an instance, right? This is an instance. Now, this Fido being an instance of dog, if we know that there is a special case that Fido's tail has been chopped off, then this does not hold. Therefore, I inherited this part by default because nothing was known to the contrary. If anything is known to the contrary, that will override. Whereas, in the case of generic systems or generic properties, we do not have the scope of overriding, because that is generic to that class and any subclass will have to inherit that. So, in normal, under normal circumstance, we would have inferred that Fido has part tail. Now, if we know more details of this, that if we know that Fido's tail has been chopped off, then we would have inferred Fido does not have tail. Okay. So, we can supersede default values if we know more details of a subclass, or in an instance the default value inherited can be overwritten. Now, here is a classical example, birds. We know birds can fly, we know birds have feather, birds are covered with feather, all right. And we also know that penguin is a bird, we know ostrich is a bird, we know eagle is a bird, sparrow is a bird. Now, if we think of sparrow, sparrow is a subclass. Now, just let me ask a question, is sparrow an instance or a subclass? Obviously, sparrow is a subclass of birds. It is not an instance, because I can have 10 sparrows in my cage and each of them are distinct. So, sparrow as a subclass of birds will inherit the property has feather, because all birds have feather, right. Now, we also know birds can fly. Now, therefore, we can also infer sparrow can fly, because sparrow is a bird. Now, you see that has feather is something that is common, but can fly is not that generic, because if we take the example of ostrich, then we will see that ostrich cannot fly, but ostrich has feathers. So, ostrich being another subclass of birds will inherit the property of has feathers, will also automatically by mechanism it will inherit the property can fly, but because we know something to the contrary specific to the subclass ostrich, that will be overwritten and we will infer that ostrich cannot fly. So, here is that example. Ostrich is a bird, by default we infer that ostrich can fly. but if at the ostrich subclass we know that it cannot fly, then we modify the inherited inference to ostrich cannot fly. Now, this is a very important and powerful means of reasoning, and this one is can be discussed in a little more detail. Two types of reasoning we often talk about. One is monotonic reasoning. Monotonic reasoning means whatever we infer at a particular point of time, given some facts, will hold. All right. So, anything that is inferred at some point of time t will not be invalidated by the arrival of some more information at later point of time. All right. So, if we go along this timeline and we are inferring at this point, I infer say some x equals to 5 for example, all right, at this point of time. Now, if I at this point of time which is coming later, I cannot invalidate that reasoning, all right. It is not like a program. So, let me change this example a little bit, that may be confusing. All right. Say instead of this we say we infer at this point that Tom is a man. All right. The arrival of other facts are being inferred at these points of time during the reasoning process, but never will revise this. All right. We will add on new facts here, but this will not be revised. On the other hand, the other type of reasoning, that is called non-monotonic. Non-monotonic reasoning means whatever I have inferred at this point of time, with the arrival of new facts or information that I am generating, this can be changed. It is possible to invalidate that. And you will see that this default reasoning is nothing but an example of the same. All right. You see, here we have done exactly the same thing, that we had made an inference here, but after that, as we knew, as we came to know more fact about ostrich, we could override that. Now, these default values can be overwritten, but generic values cannot be overwritten. All right. So, with this discussion, let us see, what would be the, if we just think of a procedural form. Suppose you want to write an inference machine. Of course, if we want to use semantic nets as a valid knowledge representation scheme, then we must have an inference mechanism for that. And so, we will have to write a procedural code which will work on this semantic net and will be able to infer new facts. Now, what we want is, we want to find the value of an attribute for an object. All right, value of an attribute for an object. What is that object? For example, Nelly is an object, or as we had seen, Fido is an object, or maybe mammal is an object. Now, we want to know whether mammal has part head, or Nelly lives in Africa. So, that means if I have a query, does Nelly live in Africa? In that case, what am I trying to do? I am going to Nelly, that particular object Nelly, and I am trying to see whether it has got a relationship, lives, and if it is, if such a relationship exists there, then whether the value of that link, I mean the link is leading to another value which is Africa. That is how we go about. So, essentially the queries, in order to answer the queries, whatever queries you form, we can form that in the form of an attributes value that we are seeking. For example, if we take an earlier example like has part, does elephant has head. So, basically what we are trying to do is we are looking at the object elephant and we are trying to see whether it has got an attribute has part which is leading to head. Therefore, in this case let us see, we are setting a list L to contain the node corresponding to O. So, we are setting a list, linked list sort of, which is containing the node corresponding to the object O, and we are setting the current node to be the next node from L, because we have to traverse that overall link. All right. So, we have to traverse that link. If there is an arc labeled A, that is the attribute we are seeking, if that is there, it points to the answer. We get the answer if we get it over there. Otherwise what do I have to do? Otherwise I will have to traverse that network. So, in order to do that, we will add to L all the nodes pointed to by the instance or subclass arcs coming from the current node. So, if we just go up to an example before, say for example, here I want to have I have got a query, where does Nelly live? Now, this where does Nelly live, that can be translated into a form of a query. Where does Nelly live? Now, this question can be translated into a form of a semantic net, like I have got Nelly lives in some value which is not known. I could have put a query or I could have put x. Now, what is the value? I want to instantiate this particular value, right. I want to find the value of this value from the net. So, this is my query semantic net, you can think of as if it is a template with which I am going around in the semantic net and I am trying to find the best match. Now, what would have happened if with this query I start my journey along this semantic net. Now, here unfortunately I do not find a match, because here I am not finding any arc coming out of Nelly. So, I am making a list with Nelly and it is pointing to all the arcs which are connected by is a or instance, subclass or instance type of relationship. So, right now in that node we have got only elephant. So, now we come to this elephant, and as we come to this elephant, what are the next possible places to go? So, in that list I add mammal. So, if I do not find the answer here, I have to go up and look into mammal, whether that link can be lives in link can be answered. Now, here as I go in, I find that the lives in link is available here, and so my answer is Africa. If my query was does Nelly have head, for example, a funny query, but then I would have started from here. I would not have found the answer here. I would have gone up. Again, I would not have found the answer here. So, the link to the list would have included this node and would have gone up in this way till I find this answer. So, now let us again go back to that algorithm. So, if we do not find an answer, we add to L all nodes pointed to by instance or subclass arcs coming from the current node, and if L is not empty, that means there is a possibility of exploration. We will set the current node and will look into that current node to be the next node, and we will see that if there is an arc labeled A at that point. All right. So, this is the search mechanism that we use in semantic nets. Now, here is another example. What is the hair color of Marcus? Now, let us look at the semantic net. What does it say? It is, we have seen a similar example in the last lecture. Man is a class, hair color of man is black. All right. Is it generic or is it default? It is default, because we are assuming this, there are people with hair color brown and other types. Marcus is an instance of man, and Marcus is married to Madonna and whatever. Now, this is a semantic net. Some give, I mean, Marcus gave Madonna measles, that sort of example we have already seen. Now, if in this case we want to answer the question, what is the hair color of Marcus? So, obviously, the net that will be is Marcus with an edge hair color X, which we do not know. Now, and we try to match with this, I make Marcus my current node. Now, no arc is coming out of Marcus with the relation hair color, but there is instance or subclass. You see, I am not traversing this at all. Please note that. The only thing, the pointers that I am putting into the next possible nodes are either the instance or subclass type of relationship. So, here we take man and we find that man has got a hair color. Therefore, Marcus is inheriting the answer. Marcus here, the hair color of Marcus is black. That is how we carry out inferencing in semantic nets. But there is a major problem over here, and that is known as the case of multiple inheritance. And what is this multiple inheritance? The problem will occur if an object inherits the same attribute from two different classes. For example, here you see Fred is an instance of pet bird and is an instance of ostrich. So, Fred is an ostrich that has been kept as a pet. Now, ostrich has got the property locomotion is walking. So, ostrich walks, all right. Pet bird is a subclass of bird and its locomotion is fly. Now, Fred is inheriting from two subclasses, ostrich and pet bird. Now, how do we infer? If we say, does Fred fly, how do you answer? What is the, or rather in terms of this net, if my query is formed as, what is the locomotion of Fred? Now, I can choose, I can say, I start with this, I do not find any locomotion edge from here. So, I can go up this string and come to ostrich and find that ostrich has got a locomotion edge. So, I infer walk. But what if I had chosen Fred to be an instance of pet bird, and what would my algorithm lead to? I would have come here, and here I do not find an edge. Therefore, I go up. I have got no way of going on this level. So, I go up and there I find locomotion fly. So, I could have inferred that Fred flies. So, there can be different answers. How to handle with this? One thing is that suppose now you if you know about different search mechanisms, if I had done depth first search, then I would have either gone to this answer or to this answer. But if I had done breadth first, then I would have got both the answers, fly through this path and walk through this path. Now, my common sense would have told me that, well, whatever is more specific is more correct. So, what is more specific? Whatever is down the hierarchy. So, walk is more specific. That is one way of handling with this situation. Now, so inference technique options in such scenario is something like this. To deal with multiple inheritance, we need to add something to determine which class will take precedence. For example, in this case, we can say that, well, pet bird will have precedence over ostrich, or ostrich will have precedence over pet bird. Depending on the particular application, you can decide on some policy to do that. In general, we want the most specific class to be used, all right. So, we could simply use the path length. We could simply use the path length, thus the depth. The notion of inferential distance can also be explored. So, it could be something like this, that the path length of fly is 1, 2, 3, or 2 at least, 1, 2, and the path length of walk is 1. So, whoever's path length is less is more specific, and that is more valid. We could have taken that. Now, here there is no hard and fast answer, and depending on the application, often we have to select a particular policy. But still there can be always problems. Like here is another example. Rita, a girl, is an instance of a teacher. Rita is a teacher and Rita is also a student. The same Rita, you see instance. So, Rita goes to teaches in a school and also goes to a B.Ed class where she is a student, all right, or some postgraduate class where she is a student. Now, the personality of Rita is confident when she is as a teacher in the class, but the personality of Rita is rather shaky when she is a student. Now, if we have to answer the question, is Rita confident or shaky, it is really difficult, because the path length will not lead us anywhere. And what is the personality of Rita? We are getting two different answers at the same distance. So, that problem will remain. So, this is a problem of semantic nets, and this is one of the problems. Multiple inheritance has always been a problem, and it is a very practical problem, and there has been practical solutions to this. Now, semantic nets that we have discussed is a very important basic tool, and later on we will continue a little bit more on semantic nets in the next lecture, but ultimately from semantic nets we will go to frames, which was proposed by Minsky, and from frames at least can be considered as a predecessor of the object oriented systems, and we will see how the notion of semantic nets has been applied in frames. So, these ramifications we will see in the next class, but before that let us end this lecture with a quiz. Take it down. Draw a semantic net structure that depicts the following world knowledge. Birds and mammals are both animals. Animals can walk. Cats are animals and eat rodents. House cats are varieties of cats which eat mice. Morris is a house cat. Birds can fly. Penguin, sparrow, eagle are all birds. Penguins can also swim. Fred is a penguin. So, this is now in that way I have just put in a number of facts, and please try yourself to depict it in the form of a semantic net, and you will also find that it is possible you can add on more sentences to this and enrich the semantic net. So, before concluding this lecture, let us quickly summarize what additional things about semantic nets we have seen in this lecture. We have first of all made a distinction. Till now we were just talking of easy relationship, but there can be subclass and instance relationship. And the major inferencing mechanism of semantic net is through inheritance mechanism. Now, when we inherit the properties from the superclass, inheritance mechanism means the properties of the superclass is inherited by the subclass and the instances. But there are two different types of properties, generic properties and default properties. In the case of default properties, if nothing is known to the contrary, then the default values will hold, but if at a lower level, that is at a specialized level, a subclass level, there is some overriding fact that will dominate and the default value will not hold. And the algorithm of inferencing is to make a template of query semantic net and try to find the best match by searching through the links in the semantic net. And while we do this search, usually, and that is what is natural, is that either the instance or the subclass links are traversed, and we can answer so many questions if we represent the facts known, the world facts in the form of semantic nets. We will see that lot many applications of this later, and it is still being used, though in different forms, and frames and object oriented systems are, we can say that, two different outputs or products of the semantic net concept.